Next, we will discuss how to do calculus with the hyperbolic functions. We can find the derivative of the hyperbolic sine function by first applying the linearity rule and then differentiating each part separately. And then finally recognizing the pattern. The derivative of the hyperbolic sine is the hyperbolic cosine. Similarly, we can find the derivative of the hyperbolic cosine function by first applying the linearity rule and then differentiating each part separately and then recognizing the pattern. The derivative of the hyperbolic cosine function is the hyperbolic sine. We can find the derivative of the hyperbolic tangent function by first applying the quotient rule and then recognizing the identities. The derivative of the hyperbolic tangent function is the hyperbolic secant squared. We similarly can find the derivative of the hyperbolic cotangent function by first applying the quotient rule. And then recognizing the identities. The derivative of the hyperbolic cotangent function is negative hyperbolic cosecant squared. We can find the derivative of the hyperbolic secant function by first applying the chain rule and then recognizing the identities. The derivative of the hyperbolic secant function is negative hyperbolic secant times the hyperbolic tangent. Finally, we find the derivative of the hyperbolic cosecant function by first applying the chain rule and then recognize the identities. The derivative of the hyperbolic cosecant function is negative hyperbolic cosecant times the hyperbolic cotangent. As a result, we obtain the following formulas for the derivatives of the hyperbolic functions, and the following formulas for the antiderivatives of their derivatives. Let's, for example, find the derivative of the following function. We start the process by recognizing that we have to find the derivative of a composition of the hyperbolic secant function applied to the reciprocal function, which is equal to the following expression, in which we know how to find all the components. We get the final answer after plugging everything in and simplifying. Let's, for example, find the derivative of the following function. We start the process by recognizing that we have to find the derivative of a composition of the exponential function with base 3 applied to the hyperbolic cosine function, which is equal to the following expression, in which we know how to find all the components. There isn't much to simplify here after plugging everything in. Let's do an example of an integral. We first recognize the pattern and rearrange the integrand. Then we set up the substitution by setting a new variable, let's say t, equal to the hyperbolic sine, and finding the differential of t. Next, we plug everything into the original integral and notice how, because of the discovered pattern, we have nothing but the function of t left in the integral. We finish the process by finding the antiderivative and plugging the original function back for t. Let's do another example, this time of a linear substitution. We set up the linear substitution by setting t equal to 4x and finding the differential of t and expressing dx in terms of dt. As a result, we have a simple indefinite integral in terms of t. We continue the integration process by finding the antiderivative and replacing t with the original function. We discussed how to differentiate and integrate functions that have hyperbolic functions as one of their components.